Okay, good evening, good morning, good afternoon, depending on your time zone. Tonight, we are going to go through the design phase of the system development life cycle practically. In systems analysis and design, there is no way you can finish the analysis and you don't design. But now we want to do it in a more practical way, where we need to have some techniques like the unified modeling language techniques to do or to accomplish the uh, design phase. And we are going to be using a unified modeling language UML techniques. For example, the use case diagrams to come up with some designs. But practically, I want us to walk through this together. I want us to walk through the design phase together, practically, step by step, so that we can get to understand how things work properly together. I want to launch my browser. And I go to Lucidchart. Lucidchart is a tool that can help us come up with the designs. So you don't need to worry about maybe registration, maybe subscription. It has a free plan that we can use to do what? To come up with our designs. Yeah. Now I want us to go through this together. Yeah, we can see the chart. Let us go through together. But I told you have to keep in mind, yes, we are doing designs using UML techniques. UML, like we did or discussed in our previous lecture, we agreed and said that UML is just a way to visualize systems or databases. You get, these are frequently used so much in software development. Yeah. So we are going to focus much on the use of use case diagrams this time round. And every time we talk about it, please refer to our previous lecture where we discussed extensively. The recording is there. We are on our model class where we discussed extensively what use case diagrams are and so on. But briefly, I need to let you know that yes, we are going to be focusing much on the components that makes up a use case diagram. That is the systems, the use cases, the actors, and the relationships. Why this diagram? Sometimes you realize that you need to communicate. You have an idea, you have a concept that you need to explain to others, but they completely fail to get it the way you want them to do it, to perceive it. Yeah. For example, one time I have ever conducted a class where it had quite a number of learners, and one of the person who was seated next to me, I told him a certain communication. Actually, I recall what I said was, your university is one of the best learning institutions on the continent. Now, I told him to pass the information onto someone who was behind him. You get, yeah, behind him. And what happened is he did so. So that person also did the same until the last row in the lecture room. Unfortunately, by the time the information reached the last person, it had already changed. We don't know where it changed from. But when we asked the last person to receive the information to tell it to the entire lecture room or class, everyone busted into what? Laughters, because what was communicated, what the person was communicating was completely different from what I communicated to the first person who received the what? The information. Therefore, even when it comes to software designing, software development, such incidences do what? Happen a lot. Now, to avoid such, we need a common language that everyone can understand, everyone can speak, and people move, because every time people get wrong requirements or wrong designs, then just expect a failure of a system. Now, to avoid having, systems failing or producing different requirements from the expected ones that were specified in the beginning, we needed to have these designs properly made up. Therefore, the need for use cases, because they are so good when it comes to communicating, informing, and influencing what? Software designs. For example, when it comes to communicating very complex situations or systems, so they do it in a more simplified way. Like I said, yes, you can sign up, but I think I already have an account. Sign up is for free. So let me check. Esulubowa at umu.ac.ug. Let me check if I have an account. Um, Let us wait and see. Good. We are there. We are there. We are there. Lucidchart is a tool that I believe is very easy for each and every one of you to do what? To understand. But I want us to go through step by step so that we can come up with something that everyone can base on to replicate and make their own designs depending on their problem domains, depending on their topics, and so on. You get. So how do we now create a use case diagram of any system? Now let us use let me first. Okay, now let us go with a blank what? A blank diagram. I want us to use something new so that people can understand this from scratch. Let us go to blank document, blank. When you click on blank, yes, it is loading. Blank. Let it load here. It is taking long. Let me refresh a bit. Let us go to create a new one and see if it can load. It is taking long. It is taking long. Let me refresh a bit again, once more. If it doesn't work out, let's go to use another browser. Lucidchart. Yeah, let us do this together. Let us hope this can succeed. Okay, okay, good. Now, this is the Lucidchart page, blank the way it is. Now, what happens is when you receive this, you realize that, excuse me, excuse me, you realize that since we are going to create UML diagrams, but here when you look around, it has only shapes, it has maybe flow charts and these standard ones. So what you do is you can go to click on more shapes, and then it is going to load a list of them. Then we just look for UML here, and then we tick it. When we tick that, you see that it is going to bring a list of examples for UML technique diagrams like UML class diagrams, use case diagrams, and so on. Good enough. Use case diagrams are also ticked. Then we can say use selected shapes. Now you realize that when now we scroll here, our use case diagrams shapes where they must be on the list. Use case diagrams. Where are you? Where are you? Very good. UML use case what? Diagrams. They are here. So we can easily use these shapes to formulate our what? Our new proposed system. I told you that use case diagrams have systems. They have relationships, actors, as well as use case themselves. You get. So, and in our previous session, I told you that a system is whatever you're going to do it to develop. One of the components of a use case diagram is a system, and a system is whatever something you're going to develop. And this can be a website, it can be a system or a software component, it can be, you know, an application, it can be anything. And this is always represented by uh, this box. Is this a rectangle? Yeah. Then we can design something like maybe banking application. Banking app is the system we are going to do it. We are designing. You get. So now, uh, that is a system, one of the components. And now we need to identify actors. Who are the actors of the banking application? Now, when we talk about an actor, this can be someone or something that uses our what? Our system to achieve a goal. This can be a person, it can be an organization, it can be another system, or even an external device that you connect to our system to achieve something. So who is gonna be using our banking application, if I may pose a question to you? So obviously the what? The customers. If we were designing maybe a university application system, then obviously the actor would be students. Now let us actors are always represented by this. You get? Yeah. Then we can call this customer. Then we get another actor here. Who else do you think is gonna be using our application? Obviously, is the bank. Why? Is because we cannot design a banking application that you will not link to any banking what institution. So we have the two actors here. We have the customer and the what and the bank. Now, customer. Uh, is one that will obviously go download and use our what? Banking application. Then the bank will be there to provide information to our what? To our application. If we are designing maybe a universal application system or application, then obviously this would be maybe UNEB as the other actor where we can link our application to in case we need maybe to verify if a certain individual did senior six and so on. Please note that actors are just external objects that don't, that is why you see they are not within the system we are designing. Yeah, they are just the external. You get, that is why we place them outside our what? Our system. So we need to make or think of actors like what? Like categories or types. That is why you have not seen me here typing maybe Mildred. You get, or coming here and type maybe my bank. You get, yeah, we are not being specific because the UML or use case diagrams, the high level what diagrams. So that is why now here we are not personalizing, but we are like taking a category. Yeah, we are considering it as a category. That is why we have customer and uh, bank. You get, that can be much better. But what you have to know is that we need to we need or we have two types after of what? Two types of uh what we call actors. Yes, we have two types of actors where we have the primary actors and then the secondary actors. Now, primary actor in this case is the customer. Why? Because the customer is going to initiate directly or is going to initiate the use of our system by pulling out their phones. They go to Google Play Store, they download the application, and then obviously start using it. You get to open our banking app, you get, and do something with it. But then when it comes to the bank, why a bank is being considered as a secondary actor is because it's just reactional in nature, whereby the bank will only react once a customer does something. For example, customer goes to the banking application and check balance. That is when the bank will now obviously engage with our what? With our system and provide the what? The information that we are requesting it to do so. So primary actors should always be on the left side, and then the secondary actors come to the what? To the right hand side. You get? Yeah. Then we have already indicated the system as one of the components of the diagram we are trying to come up with. Then the actors. Now the third component we are going to also come up is the use case. Now, what are use cases in this case? Use cases always over they will always use uh, these oval shapes to to identify or indicate use cases. Now, use cases, what do? They describe what a system does. They represent an action that accomplishes something like sort of a task within the system. For example, this can be like a futures, the way how you can see that maybe our application will be uh, providing login and so on. So what does the bank application going to do what? To offer to the customer? These are the use cases we are talking about. For example, we can say we are assuming that now you already have the banking application. If you already have the banking application, what is it going to offer to the customer? So obviously then we shall have to say, we shall have to, we expect the customer to be able to log in. You get, yeah. So we can have login as one of the use cases. To allow the customer to log in, to also allow the customer, what else? we expect that people can always come to our application and check for what? Check for balance from their bank. Check what? Check balance. What else do we need to do? Like, what else do we want people to always do while they are on our banking application? We can say we want them to also transfer funds between different what? Different accounts. So we can come and say transfer funds. Yeah, yeah, we can say transfer funds between accounts. Uh, this is check account balance, transfer funds. What else? Is that all? Maybe we can also say we need people also to use our application to make some bills payments, or we can call this make payments. People can use our application to to make payments to their bills. Yeah. So we can now just imagine maybe this was a university what? University application system. That means we would do maybe have cases like would have use cases like login. We could have maybe also yes uh, maybe check results, uh, maybe upload coursework, and even maybe make fees payments and so on, depending on how and what has been specified as one of the features the system should offer to the what? To the users. Uh, then we now go to what we call relationships as another component for the use case diagram. When we talk about relationship, a relationship helps to show interaction between the use case and the actors. You get, yeah. How the how do actors now interact with how do actors interact with the system, and what do they do? So, and therefore we need to show the relationship between the actors and the what? The use cases. So let's do this together. We shall use association relationships that we can draw using solid lines. Solid lines. Mm. But there is a rule that you have to know, which says that, each actor, the way you see actor bank and the actor customers, has to interact at least with one of the what? Use cases. You get. So now let's do this together. Where do we get a solid line? Okay, we can borrow this from, yeah, yeah, where we can say, we can, yeah, a customer can log in. A customer, what else can a customer do? Can check balance. Okay. Some come here. So okay, you are not seeing what I'm doing, but basically I've just copied and pasted the same solid line. Or I can just do it again manually. By clicking on it, it will come. So if it comes, here. I move it. Yeah. Then customer, yes, also has to make transfers. So I go back, I use the same. Then we also have to indicate a relationship for making payments here. These ones, everyone will do them at their ample time properly. Yeah. So that is relationships, but like you remember the rule I told you that each actor has to interact with at least one of the use cases. So since we are done with that, showing how customers and what they do with the system, then we also need to know what does a bank do with our application? How do they interact? On what occasions do they do what? Interact? Yeah, so we use that solid line to show the relationship between these. So customers will interact with the rest of the use cases like I've indicated here. Then when we go to the secondary actor, which is the bank, should also have relationships with these what use cases. We are not forgetting the other rule of ours that at least there has to be what? There has to be some bit of interaction. So now let us ask ourselves which use cases will the bank interact with. Bank will provide correct amount of, uh, balance when a customer asks for one. Then a bank will also make transfers plus making payments, meaning that, yeah, we need to draw uh, like solid lines here to indicate the relationship between our application and the what? The bank. Okay, let's do this. Yeah, the bank will check the account balance. Yeah, when the customer checks the account balance, the bank is the one that is going to respond by giving that balance that it has for that particular customer. Then transfer funds. Okay. Then we also do the same. Mm. But now here, since this bank is not the one we log into, so there is no need to draw a line between the login and the what? And the bank. Yeah. Because this process happens within the application is where we log in from. So basically that is it. Actually, there is no need for the bank to get involved within the login process because the login process happens within the what? The app itself. So what maybe happens is what happens is verification. Yeah, verification can also happen just to confirm whether who is logging in is the actual user of the what? Of the account. So now that brings in other type of relationships. That is what we call the include relationship, which calls for what we call what we call let me give you a scenario. When the customer types in the login information into the application here during the login process, our banking app is going to verify the password or basically the login details or login credentials if they match with what is in the uh, database. You get, yeah. So that is validation. You need to check, you need to validate your system whereby in a case the customer enters wrong details, the system should react by sending error what? Error message. So for example, we can even go here to, let us go to our e-learning. Let us go to model. When we say e-learning, let us go here. You see what I'm talking about. If we put wrong password here, what is going to happen? You see that the system returns an error message, invalid login, please try again. You get. So this does not happen by mistake. It is designed. You get. It is designed in the same way I would expect someone who has done software engineering, someone who has done systems analysis and design, to also design systems that react to what? To situations from the actors. You get. So, because you know very well that in information systems, uh, what we call CIA is very, very important. Confidentiality, integrity, and availability. Now, confidential information now like of the bank cannot be disclosed to even unauthorized what? Users. You get. So, meaning that you have to verify. Now, it brings in other type of relationship where we talk about the include that can, which I actually explained very well in the notes that you have on Moodle, as well as the video that we recorded while having a lecture for that. So we can have to create new use cases for the include relationships, that is to verify if the person trying to log in is the actual user, verify password. And if not, then we have to return the what? The error message. Yeah. So let us introduce the include the relationships here for for verify password, pwd verify password. Then can also create another one here. And create another one called display error message. Yeah. Now these ones, the include relationships, as you will read in the what? In the notes. These ones we can use dotted lines to indicate that. Where do I get them? Here. Where do I get some dotted lines to show this include relationships? When you get time, check properly for the dotted lines that we can use there. Okay. I'm trying to look for those lines that we can use here to indicate the include relationship between the moment the login happens, then the verification has to do what? To take place. So it is only when the login happens is when the include relationship can also do what? Now take place. You get? Yeah. So we cannot have the include happening when the initial relationship has not done what? Has not taken place. The same way we shall do when it comes to uh, uh, when the customer wants to make payment. For example, here, when the customer wants to make payment, then we shall also have to introduce other relationships, other include relationships. For example, you have to we can, yeah, we can provide the user with the options. For example, you want to make payments from which account? Let's assume maybe this banking application has what we call the wallet. It has the wallet as well as maybe the banking account type, which can be savings account. So we can say we are going to have two more relationships here. We can have maybe pay through what? Through wallet. Or we can say pay from savings account. You get, these are also what? Relationships that uh, include in nature. What you do is you connect this to this by using dotted what? Dotted lines. So it is this simple kind of work that I want you to do when it comes to the other assignment. But now for your case, what you do is you base your design. Don't forget also to include the dotted lines to indicate the included relationship between the activity for login and verify password, as well as displaying this, as well as for making payments through the different options, either through wallet or from the savings account. So this is incomplete, but I'm going to stop here. But in your work, I don't expect you to see incomplete stuff. So what you do is you from your problem domain or from your topic that you identified to come up with a use case diagram that clearly indicates the actors, the system, as well as the use cases and the relationships. I won't be demanding you anything. You first do that for me as a way of accomplishing your assignment. Then we can save this as sample use case diagram. Yeah. So we can even go to export it. You can import. You can do anything you want. But now for purposes of assignments, I think you can export this to PDF so that we have it in a better way. But what you do is as you rename your document, as you name your document, make sure that it has your name somewhere. Yes, it has your name somewhere so that, yeah, it has your name, not on saving, but like this system, the system should have your name. For example, we can say this is Mildred banking application. Yes, that is what I mean. Let us export this PDF and get it. Yeah, and that is what you put on your model submission. Otherwise, what you do is do the work, and let's meet in our next session, and you ask whatever question you want to ask regarding how to come up with something better using Lucidchart. Thank you very much, and we meet again. Bye for now.